This is the 1-5 mini lesson. You'll take notes on this video, add it to the same notes that you've been using in class all along for Chapter 1 so far. Stop the video wherever it's necessary to make sure that notes are in good shape. That means stopping to get something written clearly, to add a diagram, to add a note about something I said that you want to add to what you understood or something that made sense to you and you want to write it in such a way that you'll be able to go back and use these as good study notes. Complete the 6 investigation definitions. I'll remind you of this at the end. You'll read the section, complete the assigned exercises, and correct them from the online key. 1-5, the mini lesson, is on diagram assumptions. Triangles are the things you'll be defining, and they're triangle terms you've likely heard before. So the part that will be covered here is those diagram assumptions. So before you, what you see is this list of sets of things you should assume and you should not assume from now on about things that you see on a geometry diagram. First and foremost, what you can assume, unless it's indicated otherwise, is that all the items you see on a diagram, like that orange line, the green ray, the purple ray, and the black ray, that they are coplanar on the same flat surface. Unless it's drawn to look three-dimensional or indicated in some other way, they're on the same flat surface. So things you can assume. GHS is a straight line. In fact, we don't even talk about straight lines in math very often because line indicates that it's straight. Therefore, GH and S, no one's messing with you that that's 179.5 degrees. That is actually a straight angle, a straight line. Collinearity of points. Points G, H, and S are physically laying on that line together, so they are collinear. Points G, H, and Z are clearly not collinear. We're not going to have a situation where the point's going to be sitting like this, so close to the line that you can't tell. If we want to indicate a point is on a line, it will appear to be. If we want to indicate that a point is not, it will definitely be clear that it is not. Betweenness of points and relative position means that what we know is that G is to the left of point H. We don't know how far to the left, but G is to the left of point H. H is between points G and S. Things we should not assume are basically things our eye and our brain sometimes want to assume, or that in other subjects that aren't math might not be indicated, but we need to think as a mathematician in that these would be labeled or marked, or we would know some relationship that would demonstrate that they would have to be. So we should not assume things that appear to be right angles are actually right angles, or that if they appear not to be, that they aren't. What I mean by that is we can tell that the angle at point S, because it's marked, is a right angle. We cannot tell about the angle formed by GHX, that purple ray and the orange line. We can't tell if that's a right angle or not. Similarly, we can't tell if angle ZHS is a right angle or not, just because it doesn't look like it or does. We'd have to have some marking or some relationship that we know has to exist. Congruent segments, just because they look congruent doesn't mean they are on a diagram. They're not necessarily drawn to scale. So while it looks like the distance from point H to X would be the same as S to Y, we don't know that. We don't know that they aren't. So in other words, we don't know anything about the length of those segments, whether they are or not congruent. Same for angles. Relative sizes of segments, same thing. We should not assume that the angle that ZHS makes isn't congruent or is smaller than the angle that XHS makes. So just because it looks bigger or smaller, we shouldn't assume that or use that as a fact. So we'll practice a little bit together, and then I'm going to give you some try-its that you could record and try yourself. So some that we'll do together. Things that should or should not be assumed on this diagram. This would be a good time to stop the video, make a really decent sketch of this in your notebook, and add to this things that make sense to you as we go through it. When you come back then, join in. Things we could assume on this diagram. The first thing we could definitely assume, or maybe not the first thing, but something, is that points A, C, and D are collinear. Same for the other 3 points that appear to be on the physically same straight piece. Points B, C, and E are collinear. We could also assume some things about what's not collinear. We also can tell that those vertical angles at point C are congruent. That's not even an assumption, that's something we actually know. Okay, they are indicated by those congruent markings that you see, and therefore we know that. That's been given to us as a fact. Things we should not assume about this diagram. anything about the measurements of angle A, B, angle D, angle E, other than that they're less than 180 degrees. Okay. We should not assume things like angle A's measure would be bigger than angle C's measure. We don't know that. Okay. So on these next ones, I've got try it listed. You could stop the video, sketch it, try to think through just in your head and answer these questions, and then come back to the video and decide how you did. So should we assume that points S, T, and V are collinear? Yes. Should we assume or know that the measure of angle S in the diagram is 90 degrees? No. Should we assume that measure of angle R is less than the measure of angle T? No, we have nothing to support that it is or isn't true. So we don't know. Same with this, we have nothing to tell if that measurement of angle S is truly 90 or not. Should we assume that point T is between points S and V? Yes. Should we assume point T is not the midpoint of SV? This one we want to slow down because that word not is in there. Should we assume that T is not the same distance from S as it is to V? The answer to that's no. We should not make an assumption about the relative length of ST compared to TV. It's possible that is the midpoint and it's poorly drawn. It's possible it isn't the midpoint. It would depend on what kind of markings and other things we could tell. Otherwise, we would have to say we don't know. Another try, a set of 3. You'll see these in your book as well. Again, your option is to stop the video or to just play it along in your head and see if you are starting to get the big idea. This is a deceptive picture outside of geometry or outside of math class. You might say that's a square. There's no evidence, though, mathematically that it is. So diagram assumptions we're allowed to make is that that's definitely a quadrilateral. Q to R, R to S, S to P, P back to Q, closed plane figure consisting of straight segments meeting at their endpoints. All those things that are definition of polygon is met, and it's 4 sides. We don't know if it's a square, a rhombus. We can't tell about parallel or perpendicular or congruent sides. The next diagram has a lot of lines that are drawn, so things that we do know, that the lines indicated as parallel by the pink arrows are parallel. Please take note of that in notation so that you keep thinking about how we indicate that. We do know that all the lines are on the same plane. We could also have told that about the quadrilateral. Okay, when we said it was a quadrilateral, that would actually be part of what would have to be true. And we could have a lot of different variations about, here's what we do know about points. Point A, B, and E as a set of 3 are not collinear. Any 2 points can always be connected by a line, therefore any 2 points being collinear is never a question, but 3 or more points may or may not either form a line or form a triangle. In this case, they would form some form of triangle. On the last diagram, I see a lot of stuff going on in there. Things I could or could not assume. I can assume the 4 lines that are shown are on the same plane. I can tell, not assume, but I can tell the measure of angle J is 90 degrees. Or I could tell, saying something similar that tells us a lot of the same thing, that line JK is perpendicular to line JM. Again, note that notation sample. I could tell that when those 4 segments are joined, I would get a quadrilateral on the inside. So your tasks. You have the investigation definitions to write using your good definition writing skills from section 1.3 and 1.4. So you have 6 of those. Again, not a paragraph, not an essay about them, but those steps of trying to put them into a known category and then give the 1 or 2 characteristics that must be true for it to be distinct or different from all the other things in that category. We will go over those tomorrow so that before they go in your final notebook, you've refined them on your homework page and made good additions and maybe shared some really good ideas that you have and how you worded things. After that, so that's the first task, complete the investigations. It's on page 55. Read the section. There's not a lot of reading. Maybe even look over it more than once. Be sure to look for things like the diagram on page 55 that talks about additional vocabulary about isosceles triangles. Then complete those exercises that are assigned off the syllabus in pencil. Please go online to the key and check them in ink and come ready to class the next time we see you, ready to go over some of these, ask your questions, and talk about how you're separating those details of all this. And that's it. Applause optional. See you soon.